Hi everybody, let's see if you are online. I not see anything in YouTube yet. Okay, I think it started. So
Okay.
uh, we are here today with Rodrigo. Hello
Hello,
Rodrigo.
everybody.
Hi. So Rodrigo,
Uh,
what we are going to present it today?
So today I'm going to show you guys how to use the 8X711. It's a ADC from I think is Avia Semiconductor. So it's
Mm-hmm.
very popular. It's an analog to converter used for scales. So let me briefly show you guys. So my share is already being screened, right?
Yeah, it's already.
Okay, so let me briefly show
Yeah.
the data sheet for this guy.
Mm-hmm.
So it's a ADC. It's used for weight scales.
Mm-hmm.
Uh,
Load cells, right?
yeah,
Basically, load.
we
Yeah,
need
load
to
cells.
connect. Yeah, we need to connect the load cells. And here is how we are connecting our load cell today. Of course, they are using Arduino here, but in fact, we are going to use our STM32F4 board
Mm-hmm.
that I'll show you guys in a few minutes. So there is possibility to use uh, up four offload cells, so you can have different configurations here. But in this case, I'm using just one. And when you guys use just one load cell, you need to put some resistors here uh, to wire to the ATX711. So here's how I'm writing this module, and let me show you guys my camera
Mm-hmm.
before starting code. Right? Did I miss anything, Alan?
No, I think it's okay. Just
Okay.
maybe just explain that resistors are necessary because we are using only one, as you said. If
Yeah,
you use two or four, we don't need to put that two resistors, right?
yeah. So here is the load cell. Uh,
Mm-hmm.
Here is the STM4. This is the board that you have been using for all the videos, right? So
Mm-hmm.
at least for this series. And here is the HX, and you can see the resistors there. Please don't look at my solder. It was done a little quick, so I need to.
Yeah.
to
I will try to find. I have a good soldering tutorials. It's from
Mhm.
a series from the I think from the 90s or 80s. Very good. The guy go to all the explanation first, how to wire, how to do the soldering in wires, how to use it, and
Mhm.
yeah, it seems like overkill, but if you follow the suggestions, you master your soldering skills. So
Yeah, I need. I think it's also a kind of practice things, right? So
yeah,
if you practice a lot, you eventually you be
exactly.
at least good or
Yeah,
not so bad on this.
you know,
But anyway,
after 10,000 hours, you become good. It's like
yeah.
any other things in life.
Hmm.
You need to fly for 10,000 hours.
Yeah. So let's do some coding. So I have here. So let's remove
Hmm.
this. I put this tab here.
So the idea today is show how to use it in NuttX, right? And you show
Hmm.
how to how to configure, how to create the files as well, or you are assuming we already have the files. What the idea?
So we have here another board that already have support for this. This board I think is STM4 minimum board.
Mm-hmm.
They have support. So uh, I will basically copy this file here, and add to our support to our port. So
Oh,
that's
perfect.
how we're going to work. I
Right.
think is essentially what you have done in few other sensors and
Yeah, exactly.
actuators.
Mm-hmm.
Okay, so let's start by checking if everything is. I think I just updated yesterday. I updated my repositories, so I would be not too far from the latest from the master.
Mm-hmm.
And let's just see if I have some. So yeah, we don't want this board now, this file now, because we are going to copy, right?
Yeah.
That's because yesterday I was playing with this. So
Okay.
let's remove that, and we need a clean environment, right? So nothing here, and you could have some. Okay, so it's from
June 20.
yeah.
Yeah. Not so near, but so
Hmm.
up to date, but okay. I think
I think you
it's enough.
can do the following. Uh, let's see, where is my master? Oh, yeah.
Yeah, your master
So
is also. So
uh,
yeah,
uh,
it's okay.
uh,
Just
you
one.
have time to update? I can update it for the latest.
It's up to you if you want to update. Just run the
Yeah,
git pull.
let's do that. So we check out upstream.
Hmm.
Let's git pull. Okay,
You
git log.
only your master is not updated with your upstream. Your upstream is updated.
Oh, that's strange because
No,
even the upstream seems to be pointed to this one here.
maybe the upstream is not pointed to NuttX.
I did, but I didn't change anything. So let me check the
Oh,
remote.
okay. I think I understood what happened. See, these, for example, the second is June 24. So
Mhm.
probably it's just the date um,
Yeah,
of the
the
commit,
first one.
because some people create the commit in the past, but they don't submit to mainline, and then when they submit
Hmm.
to mainline, it become very old. The
Yeah, that.
the date of creation.
So that makes sense. Let's uh, not waste any more time on this and go to the my print that I was working with and HX manama. So okay,
Hmm.
that's okay. So uh, now we need to copy ports. Oh, sorry for the arm. STM32, STM32F4,
11.
11 minimum, source, STM, 8X. We need to copy that to boards, ARM, STM32, STM32, oops, 32, okay, F401, source, right?
Hmm.
Okay, so now you have our four. Well, let's close this one here, and now you have our new file here, and uh,
Change
let's
the
starting
name.
by
Change the name the board.
yeah,
The,
let's copy relative path here. Sorry if I'm lazy of typing, but this avoids some mistakes.
yeah.
Okay, so we have here. Later we are going to
Ah,
set the
go back
pins.
there. I think they're double HC.
Yeah, yeah. Sorry for that. So
Mm,
yeah.
no problem. Mm-hmm.
You can handle later the pins, but now let's
Mm-hmm.
start by adding here
Make
in
file.
the uh,
You can copy from the minimum as well, right? If you
yeah,
want.
but I think I have here in my annotation, so
Ah, okay.
I can.
I think is analog config analog 8x711.
Yeah, so it is this string here, right?
Mm-hmm. Ah,
And
ABC,
here,
not analog. Okay.
yeah, and you have here the 8x711. Okay, so far the make depth is okay. Let's do the make CMake here. Mm, let's copy from this one here.
Mm-hmm.
And for this one, we're also going to use the same. And here, oops, 8x711. Okay, so included in the let's now, so first things, right? So add the file and add the file to make files. Just
Mm-hmm.
make and make file.
Yeah. Just
Let's
remove
not,
one here.
yeah, oh, sorry. Uh,
Yeah.
so, so now we need to put in the bring up, right? So because we want to initialize that.
Mm-hmm.
And in the bring up, we can uh,
Yeah, you can copy from minimum because it will be faster, right?
in fact, I have here in my annotations.
Okay, it's up to you.
That's okay, or do you
No,
prefer to?
I just suggest to copy because when you type, is more
Uh,
prone to make mistakes. Understand?
yeah. So let's put here from my
Okay.
annotations, right? So
Mm-hmm.
okay.
Yeah, that's fine.
I think there's another. Okay, it will fail during the compilation, but you can fix later because I know there's
Mm.
here in the. Let's check here. We did the ADC for this board before, right? And
Ah,
we
yeah,
configured this.
yeah.
So the problem here is that seems like we should be added the STM32 ADC instead of this config ADC only, because when we enable the ATX711, it's also need
Ah,
to
it's
enable the
also enabled the
ADC.
this one.
Yeah, but okay, let's see. It's failing, so we can show how to identify and fix that. So I think for the bring up, it's okay.
Mm,
And now we need to define the pins, right?
yeah.
Let me add the pins here. I will add here in the this. So I put here in the end. Okay, GPIO. Okay, here is okay. So I will put here the later I can put a better comment just to identify here. Okay, and I will copy from this is from minimum board, right?
Mm-hmm.
But in our case, I have the annotations here to avoid going and forward and back to the. So here I need to put here. Uh, okay, sorry, one important thing. We are going to use port B. Uh, I think it's important to say. Let me. So this. this module is connected to the STM32F4 using the SPI, reduced set of SPI, just one data, and you're going to connect that to port B, pin 1 for clock,
Yeah.
and port B.
Maybe you can show in the video in the board how you which
Yeah,
pins it is used
uh,
so it make
yeah,
clear to people to understand. By the
absolutely.
way,
Yeah.
you put 771 in the comment. Put return it
Oh,
to 711.
yeah. Thanks. A lot of types today. Okay, so let me show here. Uh,
Yeah. Now maybe you can use the other configuration to make it near the pinout, right?
okay, so let me just put back here because I will change things here. I don't want
Ah,
to
yeah.
just to, okay.
To make a close
Yeah,
up in the board.
now I think, okay, so let me see.
Yeah,
I will show
I
you
think
guys.
we need. I also need it uh, like a fixture that we can move the camera
Yeah.
in our
So
desk.
yeah, so you can see the black wire is going to GND as expected. The head one to the 3.3, right?
Hmm.
And you have the gray and white. The gray is in PB1. It's going to be connected to a clock in the board in the module, and the white is in the PB2. That's going to be the data. Let me see if I can show you guys here.
Yeah, in the module, right?
Oops. Yeah.
Take care to not
So
because the too many wires you can
yeah.
drop some connection.
So yeah. So here's how it's connected. Okay. But trust me, that's how it's going to
Right.
be connected.
So
Okay. So let's go back here. So here are going to be uh, port B and also port B here. Uh,
and
Here's gonna be
pin one or
pin
pin
one.
two this one?
The clock is pin one.
Pin one, okay. The
Yeah.
other pin two.
And here is the pin two.
Okay,
Okay, that's
right.
it should work. Let me see what else we need to change. Uh, I think we did we add the file in the make files, we add in the bring up, uh, we configure the
Yeah, the bot bring up the file, the cmake file,
mhm.
um, cmake and make file actually, and now the pin configuration. I think it's enough right now. We just try
I
to
think we need to initialize, right, the prototype for the function to put in this, right? I was checking my annotations here. The prototypes here
yeah,
because
to avoid saying, oh, we don't function not defined, right? Yeah,
yeah,
good.
let
We
me
need
see.
to include.
Okay, I put here in the end.
Yeah, need to include this. That's correct.
So, okay, yeah, I think that's all now.
Mm-hmm.
Uh, just need to configure, right? So let's go to the shell. Everything is saved.
Yeah.
Remember that it will fail, right? So that's okay. So make this clean to clean your
Yeah.
uh,
Normally,
previous configuration.
you
But
already make this clean.
yeah,
Normally, I type make this to clean dash J to use
hmm
more cores and clean make, make it very fast. Yeah, configure.
yeah.
You
I'm
are
going
going
to
to
use
use
the
USBNs.
yeah the use bin.
Mm-hmm.
And now let's make menu config to configure the oops config. to configure that. Probably I'm going to want to try. Whoops. So the ADC ATX 711 is the first configuration I'm going to enable that.
Mm-hmm.
Uh, Going inside this, I think we need to enable this one here, and then go to AV semiconductor support and enable this. Okay, I think that's it. Let's check if there's also the example, of course, because we want
Yeah.
to play with it. And okay, so we have the ADX X711, the examples, uh, just the program name, stack size. That one is for minimum. I think the configuration is pretty simple.
Mm-hmm.
There's not so much we need to do.
Yeah, it's very straightforward, right?
Yeah, let's try this. It will fail, but you can show you guys why.
Then it registered the function. There's some warnings.
Yeah, that's because GPIO, right? We have this
Oh
very
yeah,
long time.
yeah, I understood it because average is defined without some value. For example, if you put it initially as equal zero, this warning will be fixed. So
Mm-hmm.
you can fix it. But yeah, as you said, the ADC
Yeah.
setup failed.
So I think a way to fix that is going to be going here to bring up, and here we can. Uh, I have I have we made change for this.
Hmm.
Uh,
How is it done in the? Okay, yeah, it's possible this way. But I mean, how is done in Minima? The or they don't have ADC setup there.
let me check. Uh, they don't have.
They don't have it.
They have
Yeah,
yeah. They have just the EX
yeah,
711.
yeah. We need to think later, like
Mm.
the best way to use it. I think actually because the config ADC is used to these the, to these um, amplifier as well to these
Mm-hmm.
8x711. So um, these configuration are shared. So
Yeah.
I think it's better to do this way. Okay, just a sec. My battery in the notebook is critical. I go back very fast. Just a sec.
Okay.
You
Okay.
can
No problem.
continue.
So
Okay, I feel. I
okay.
think I still alive.
Yeah.
Okay.
Yeah. I can hear you.
Yeah.
So
Yeah. Actually, I thought I was using my charging in other place. I went there, but it was here because I was charging the drone joystick using it.
no
I,
problem.
I just
So
removed it.
so
It was
yeah.
behind the laptop. Okay.
Sure. Sure. That's okay. So let's go back to the shell, and now it should compile. Hopefully. Okay.
Yeah. Fix it.
And I'll put the board in. I think I can somehow the cheese application exits here. So let me open again to show the board. I'll leave this here, always on top. Okay. So I will put the board in boot mode, in DFU mode, right? By pressing the the boot button and then the reset. So let's just double check because I had some problems in the past
Mm-hmm.
regarding.
Okay, it's
Okay,
in
it's here.
DFU mode.
So let's use the DFU application to load the firmware. Okay, so I reset the board and going here to another. Let's open another shell here, and we can do minicon. I think, huh, there's
There's
another
another
one.
already using it.
Oh
Yeah,
yeah,
you have
this
one
one.
here.
It was covered by the the top of the cheese here. So let's close this to avoid confusion. And so we are using the USB, so we need to enter 3 times. Okay, and let's.
Type help or
Okay,
question mark
yeah,
just to
yeah.
see the application
Mhm.
here.
So the application is here. Let's see if the device driver is in the dev. So we have the 8X711
Mm-hmm.
here, right? So that's,
Yeah.
and so let's start. I can show the documentation. Just need to here. I will show the documentation very quick. So uh, this example application have some default parameters that I will show you guys. But let's say you can change the precision, you can change the path in case you have more than one. It's not in our case now. Uh, Reverse the sign. You see that sometimes the read is in the minus signal. You can dump the current settings. We can uh, we can calculate the average of the samples before show. Set the channel.
Yeah, channel A
This
is here.
HC has 2 channels, right? You're going to use the channel A. Change it again and run the read a number of times, right? So we're going to play with this. First thing, what do you think? Let's dump the.
Yeah, show the as you did before. Show the information about the device.
So this is the current setting. You're going to use the device that is HX710, the only one that you have.
Mm-hmm.
Basically, you're not doing the average, right? Because it's one, so every read you're going to be showing the screen. You're using the channel A, uh, you're using a predefined again, and there is also this value per unit. I think this value per, yeah, so this is also another uh, way that you can configure, right? Because if you're going to use it a real scale, you may need to set these values to calibrate the scale, right? So,
Yeah.
uh, and so let's try some read. Hopefully it comes something.
Yeah.
I will, I will do this without any setting now. Let's see.
Then reading.
Okay.
Yeah.
So a
You need to
negative value, right?
calibrate right
Yeah.
to gauge the to have the zero near zero
Hmm.
value.
So it will depend from the load cell, but here in the documentation, we have an example that you can set the value for 813 and the tare to 10 So in this example, it will give you the precision about 10 grams precision, but uh, not sure which load cell was used, so it may not be the case for us. Let's just to play with this. Is that okay, Alan?
Yeah, I think so. I don't remember all the parameters.
Yeah.
Yeah, but
Let's see if the value is a little more uh, make more sense now.
yeah, I think now they
Hmm.
are make sense, right?
Yeah.
And now maybe you can change the camera again and to show the load cell, and you can put some heavy things over it.
In fact, I tried to play the some have things to put in over it, but it didn't work. I need to use my fingers to try
Ah,
to
to put more
yeah,
first. Okay.
but I can try to show. Just
Mm-hmm.
you put the support here again. If you see that what is the support, you'll not believe, but that's okay. Okay, uh, let's hopefully you'll not fall apart.
Yeah.
Let's see.
Yeah, you can
Uh,
move the camera, the board a little bit out of the camera to have more space to the
you
gauge.
see here?
Yeah, no, I mean the opposite. We don't need to see more
Okay,
much of the camera, right? Yeah.
okay. Okay, so I will put to, let's put the, oops, something wrong happened, sorry.
Yeah, your
That
support
that's
drop a little
that
bit.
was expected, right? Because
Yeah,
okay, okay, just a second.
yeah, it's okay.
Let me put this apart. And I think I will remove the support because it's a little dangerous.
Yeah,
And I will try to focus only on the,
on the gauge itself.
yeah, okay. Let's see if I can do this. Yeah, okay. How about it?
Yeah, it's perfect. Yeah.
So let's set the average for maybe 5.
I think the now you just need to set the average and the, increase the number of sample for maybe
Hmm.
100. This way you can
So
see more time it's running.
so the average I put like
The
5,
problem putting a big number for average is delay way more time, right? I think 5 is
yeah,
okay. Yeah, 3.
3.
Yeah, 3. Let's try with 3.
Okay, I will try run if only 7 samples to see if after the
Ah, okay.
disaster here if it's still running.
Ah, yeah. Okay, makes sense. Yeah, seems like
Yeah,
it's okay.
yeah. Because you see, the signal generated, the analog signal generated by the load cell is very weak, right?
Yeah,
So even if you change the wires a little bit or put the things in different distance, they will change this value. So it's very sensitive
yeah,
sensor. So that's why uh, need to always calibrate and tear this. So now I run, let's say 100. Let's see if it's okay.
oops,
Oh, again.
yeah,
Okay. Uh,
let's try.
and I will
Forced it, right?
yeah, I use my fingers to force, and you can see the changes in the values here. Let's see. So I'm pressing on side.
Yeah,
Now
press in
I'm
other
going to press
direction.
in the other side.
Yeah,
So uh, yeah, it seems to be working, right?
yeah,
Again,
in this direction
and let's go back
to normal.
to normal. Yeah. So that's it.
Cool, very nice.
it it's worked. I think uh, It's a little complicated to work with this guy. As I said, the signal is very weak, so uh, sometimes we can think that it's not working as we did yesterday, but it's just a matter of uh, we see some cool projects using some supports for the load cells in the internet. So if you
Yeah,
guys want to choose to
I
try
think,
to find that,
yeah, I think keep it in a fixed position improve these
hmm for
these
sure.
issues that you said, right? Because
hmm
normally it need um, to not move the wires, and the these plates need to be at the right positions and so on.
Yeah, yeah.
Yeah, very cool. I think this is something that can be used for many projects to create some scales, or to even for some, for example, for rockets, to people measure the thrust, the if the how much thrust, how much thrust the rocket is producing, for example. Yeah,
hmm
many users.
Yeah. Okay, so I will submit that to the main line, so anyone that has this board can play with it,
Hmm.
or even copy to another board. I'm not sure if Discover has this because now I have a Discover F4.
Yeah,
So
it doesn't have it. Only the minimum, and now if you submit to this F401 RC RS485, we have it there as well.
uh, do you
F4 Discovery.
do you think it's worth to add also on the
Yeah,
Discover?
maybe it's a good idea because this board is very common, very used by many people.
Yeah.
Yeah,
Yeah, now that I have one, I can also support for this. That would be so. I see that F4 Discover has a lot of configurations and a lot of
yeah,
uh,
yeah. And I use it in the YouTube videos, for example.
mhm.
So they're very good board to test things on NuttX.
uh, do you think we need different pull requests for each board
Yeah,
or
I suggest to separate because different
mhm,
boards. If you want
that's okay.
to add in a single pull request is okay as well, since you have different commits for one board and
Mhm,
for the board. But yeah, and but at least the commits need to be separated.
mhm. Okay, okay.
Yeah.
Uh, okay, so I think that's all for today, guys.
Okay. Thank you very much, Rodrigo. Very good presentation. Very good
Thank you.
process. Yeah.
Sorry for the problems with the camera, and
No,
hopefully I get a better support for the next.
yeah, don't worry. I also have these issues here. I need to I have articulated arm here for microphone, but
hmm
I don't have it for camera or something like that. We need to find some way, right? Like
Yeah,
more people more professional. They have
yeah,
some fixed camera in the bench, so they can zoom in, zoom out very easily. But we're still in the progress, right? We someday
yeah.
we will be in that level.
Okay, so see you guys in the next.
See you. Thank you very much. Bye
Thank
bye.
you. Bye bye.
Bye.